Okay, in this example, we're using the central limit theorem. And the topic of this video is to find the probability that a sample has a mean which is less than some value using the central limit theorem. Now remember, when you're using the central limit theorem, the key points to remember are that the mean of the means is equal to the original mean, and the standard deviation of the set of sample means is equal to the original standard deviation of the original data divided by square root of n. Okay, so here's the problem. Suppose scores on an exam are distributed with a mean of 70 and a standard deviation of 12. If 9 scores are selected, find the probability that the mean of the 9 scores is less than 64. Okay, so I want to remind you, when you're using the central limit theorem, the problems tend to be very, very similar to just general normal distribution problems. It's just that instead of dividing by sigma when you're finding the z-score, it's going to be sigma over square root of n when you're finding the z-score. So here's what the solution is going to be. Okay, I'm going to stop right here. There's more to write, but let's look at this. If it had just been find the probability that one score is less than 64, we'd find the z-score of 64, which would be 64 minus 70 divided by 12. But we're finding the probability that 9 scores have a mean less than 64. So that's what makes it a central limit theorem problem. So instead of 64 minus 70 over 12, it's going to be 64 minus 70 divided by 12 over square root of 9. See, this is the central limit theorem. And again, here's the key point to memorize. The standard deviation of the sample means is equal to the original divided by square root of n. So when we find the z-score, we don't just have sigma in the bottom, but we have sigma over square root of n in the bottom. And when you calculate this, this is going to be in the top, that's negative 6. And in the bottom, that's going to be 12 over 3, which is negative 6 over 4, which is negative 1.5. And really quick, I want to remind people there's many ways of typing this into your calculator. Me personally, when I type it in the calculator, I like to use a lot of parentheses just to tell the calculator what the numerator is and also tell the calculator what the denominator is. I use parentheses. Of course, you could do it without the calculator for some problems, like I just did. But generally, students use the calculator, and if you do, be careful with your parentheses. Use parentheses to tell the calculator what the numerator is and what the denominator is. Okay, so we found the z-score, but we're still not done. So now we got to find the probability that the mean was less than 64. So we converted it to a z-score, but to finish the problem, we're going to find the area to the left of this z-score because we're finding the probability that the mean was less than 64. So since we're finding the probability that it's less than 64, that means find the area to the left of this z-score. And to find the area to the left of a z-score, you can use normal CDF. And when you're using normal CDF on a TI-84, to find the area to the left of something, you're going to enter a large negative number. Negative 10 would work. Negative 15 would work. Negative 100 would work. But negative 10 is far enough to the left so that it will work. So negative 10, comma, negative 1.5. And when we enter that in the calculator, normal CDF, negative 10, comma, negative 1.5, you're going to get 0.0668. So this right there is the final answer, 0.0668. And I do want to remind you that we also have calculator videos that go over how to use normal CDF when you're finding the area to the left of something or the area to the right of something, or even area between two z-scores. This particular one happened to be a problem involving area to the left. So we did normal CDF negative 10, comma, negative 1.5, and that is the final answer.